Okay, we have a geometric series, and these are cool because they require like a nice little trick in order to figure out what our common ratio is and what our initial term is. So if you remember, we're trying to find something of this form. This is our common ratio. That's what's being taken to some exponent. If we have this initialized at 1, then you probably want your exponent to be n minus 1 usually. But here we're just going to go with whatever exponent we can get. So let's not do that. Let's not do the n minus 1. So we're just caring about what our first term and what our common ratio is. So how would we do that? We've got something to some exponent there, and we've got something to some different exponent, n minus 1, and we've got 2n. So that seems like difficult, right? Well, the first step you probably want to do is realize that you could do e squared, and then that's the power of n. Because with exponents, you're multiplying. So we want to have these as simple as possible. We don't want to mess around with 2n. We want n, and then we have n minus 1. That makes us feel more comfortable. But it would be even more comfortable if we had the same exponent, if we just had n, or if we just had n minus 1. I'm going to go with just having n. So the way you just get n is by realizing that this here is always multiplied by 1, right? This is always multiplied by 1. And 1 can be written as 6 over 6, right? And 6 over 6 is the same thing as having 6 there and then the 6 there, right? Still the same, haven't changed anything. Now what happens when we actually multiply these? This has an exponent of 1, and you're multiplying by something which has an exponent of n minus 1, and it's the same number here. What happens to the exponents? You might not remember this, but you would just add them. You would just add them. This is some algebra stuff. So we would get 6 to the n. So that was our goal, and now we could just do that. We could just leave here 6 to the n as long as we have a 6 out there. So notice that we have a 6 out there. We can't just change it. Now we have a 6 out there. So you don't have to do the entire algebra thing. You could just remember, if you have n minus 1 in the denominator, you could just multiply by 6 and then have 6 over n. So 6 over n equals 6 over n minus 1. These are equivalent things you could do, as long as this is in the denominator. So now that we know this, our next question is, how do we find what our common ratio is? Because that's what we're going for. We're going for our common ratio. Well, now we could factor out this exponent. Or bring it out, not factor it out. It's probably not the right terminology. We have e squared over 6, and we're taking that to the power of n. This is our common ratio. This is what we're taking to some exponent, and this right here is our first term. Well, it wouldn't be our first term in this case because we're plugging in 1, and this is not n minus 1. So it would not end up being our first term. Our first term would be e squared. But all of that doesn't even matter. We're looking for our common ratio. How do we find out if this converges or diverges? If the absolute value of this is less than 1, it's going to converge. If it's greater than or equal to 1, it's going to diverge. In our case, this is greater than 1. E squared over 6, plug that into your calculator, it's greater than 1. It's like 1.27, it's something. But it's greater than 1, and because E is 2.7181 and so on, and then you square that and divide, yeah, it's greater than 1, so this is going to diverge. It diverges.